Okay, when you take second semester calculus, or what some people refer as Calc 2, or in high school it's the I think it's called the AB calculus sequence. It's a 1 year sequence for calculus. Same thing in college, by the way. It's 2 semesters, 1 year. It says you'll derive three important series expansions for e to the x, sine x, cosine x, and those series are indicated. What's nice about these series, though, they're absolutely convergent. All right, and they're true for all numbers, complex and real. All right, so that's nice to know. The other thing about this is if they're absolutely convergent, you can rearrange the terms in any way you like. So the first question they asked me is to evaluate e to the xi. And let me write that down for you. So e to the xi, I'm using this here. And we plug it in. What do you get? You get 1. Well, it's going to be xi. Then you're going to get plus, well, that's going to be x squared, I squared, over 2 factorial, plus x cubed, I cubed, over 3 factorial. And I'm just going to say yada, yada, yada. I want to figure this out. And what does this give me? It gives me 1 plus xi. That's not so bad, right? Now, if I did this term over here, I would get, let's see, I squared is minus 1. So I get minus x squared over 2 factorial. If I did this term over here, I would actually get minus x cubed I over 3 factorial. Now, my concern is I wonder what happens next. I want to write it down for you. So I want to put the next term down. And what would that be? Let me just kind of figure that out. It's going to be x4, I4 over 4 factorial. The next one's going to be x5, I5 over 5 factorial. Well, I think I could figure those out. And so the next term, this one over here, is just going to be x4 over 4 factorial. And what's this guy going to be? It's going to be just x5 times I over 5 factorial. So I think I've done enough where I got a general pattern of it. And I can kind of write this down forever now. So it's going to be 1 plus xi minus x squared over 2 factorial minus x cubed I over 3 factorial. Then you can get plus the next term coming up is going to be minus, that's going to be x6 over 6 factorial minus x7 over 7 factorial I, plus, the next two terms would be plus, next two terms are negative, yada, yada, yada. So I think I got that covered. Let's just go to the K, and let's see how we did, all right? So what I'm seeing is they're writing this down. That's we got that. These two first terms are negative. I got that. Then 2 positives, then 2 negatives, and there's enough to get a pattern on that. What else did they ask me to do? They asked me to do something that actually kind of simpler. They asked me to just simply take sine x and multiply it by I. And this is what sine of x is, and I can certainly multiply that by I. And what would you get? Well, I times the series sine x is just I times that series. Right? And I expanded a little bit. That isn't a big issue for me. All right? Now, it goes on to say something over here, which this is B now, going on to B. It says you should be able to verify this identity now using what we just did. So what I did was I wrote down what the cosine of x is. Again, that's not a memorization skill. It's a reading skill at this point. I'm just writing this down, and enough terms to get an understanding of a pattern there. And then I wrote down I sine. We just did that. And then what I did was I kind of, just expanded it. And by expanding it, I certainly want to go in order. And someone said, what do you mean order? I mean, I'm looking at it, it's 1 plus xi. I definitely see that. And then I'm going to, squares and then cubes and so forth and so on. So I definitely see this. I see I times x cubed over 3 factorial. That's minus that. So forth and so on. I'm just writing out each term separately. And what's remarkable about this over here, it's something we just derived. It's this thing right over here. All right? So we just showed this to be true, that this and this are identical. All right? That's a nice thing to know, by the way, that these things are identical now. All right, it's a good fact to know. Okay, so next question C says it's often stated. This is stated a lot, by the way. All right, and it states that e raised to the I pi plus 1 is equal to 0, and it's perhaps the most famous equality in mathematics. It relates what some people refer to as the 5 most important numbers in mathematics, which are e, or Euler's number, I, the imaginary unit, pi, or p, as some people say, the number 1, and the number 0. It's like a compact statement, though. All right, they want us to verify this. How would I verify that? Well, we just derived that e to the xi is cosine x plus I sine x. So I'll just fill it in. It's going to be e to the pi I is cosine of pi plus I sine of pi. And again, we're trying to verify this over here. E to the I pi, or pi I, what do I write down? What's cosine of pi? Minus 1 plus I. What's the sine of pi? 0. So what do you have there? Just minus 1. What does that mean? E to the I pi plus 1 is equal to 0. We just verified it. All right, let's go to the next statement. Next question. I mean, it says, you should be able to verify this over here. And this is an important form that we've actually used in prior problems, by the way. Certainly, this is the one that's been derived in the text. All right? This is the one we've been using for the simpler problems. We've resorted to the other one because we needed it. So I'm going to write that down for you again. And what do I know? I know e to the ix is equal to cosine of x. We just spent some time deriving that using series. Multiply both sides by r. You would get r e to the ix equals r times the cosine of x plus I sine of x. All right? And we're done. We found that. All right? Now, this is the form that we've talked about in class, by the way. This is actually a better form. I shouldn't say better. Sometimes it's better. All right? You got a variety of forms over here. So we've kind of done this over and over again. All right? And with the understanding that r is, the modulus of the number, x is this argument, the angle that is forming in the complex plane. And that's it. Thank you so much for paying attention. Appreciate your time.